Welcome to the first vNews episode from MinEx CRC for 2024. Today we'll be showcasing two technical highlights. Firstly, we'll hear from Marnie Forster and the team at ANU on their work on barcoding metallogenesis. The team produces highly detailed age histories from small samples of rocks, such as drill core or chips. Researchers then use computer codes developed by MinEx CRC to give a history of how temperature has changed over time, including magmatism ages and timing of any fluid, which could include mineralisation or hard-to-see metasomatism. The unique thing about this method is that all of this information comes from the same small sample that is internally consistent and highly precise. Secondly, from Curtin Uni in Perth, we'll hear from Brett Harris and his team about a new downhole electromagnetic sensor logging tool. The unique thing about this technology is its ability to measure a range of frequencies. This means it gives multiple petrophysical properties in a single run. Drilled holes can sometimes be unstable, therefore the ability to acquire a wide range of data during a single run is faster, cheaper, and enables the maximum scientific output from an individual deployment. Caroline Tiddy from UniSA will provide an education and training update, highlighting the continued success of our postgraduate program.
Here at ANU, with innovative new instrumental methodologies, we extract highly detailed age spectra from small samples of drill core and/or rock fragments. Purpose-built computer codes for modelling and simulation then delineate temperature time histories, mapping rock fluid interaction, cryptic metasomatism and paleo-depth variation. MinEx CRC developed this workflow to allow characterisation of the later stages of the geological history from 500 to 150 degrees C of terrains being drilled into by the National Drilling Initiative or the NDI. New information is provided about basement rocks, under sedimentary and regolith cover. Mineral explorers should be able to examine patterns in a national argon map reinvigorated with the ability to show paleo-depth variation from critical times, barcoding the tectonic signature of metallogenesis. We work in collaboration with mineral explorers and the geological surveys for the public good. The explorers allow access to rock samples, providing a regional cover that would be unavailable without their help. With these samples and those of the Geological Survey, a set of samples is collected that is specifically targeted to allow the barcoding of events associated with metallogenesis on a regional scale. Common rock-forming minerals contain potassium and thus allow argon geochronology and thermochronology, as potassium radioactively decays to argon at a predictable rate. Our approach involves first developing a careful link between the geological processes and the microstructures in the mineral sample sent off for radiation. Several hours of neutron bombardment converts 39 potassium into 39 argon. On return from the reactor, the sample is loaded into a unique gas extraction system specifically designed for the problem at hand. No other lab possesses this capability. The sample can be warmed up for 24 hours, driving out contaminants and absorbed gases, leading to an unprecedented level of cleanliness and improved data quality. Through careful controlled furnace step heating in a succession of steps over a 24-hour period, Agnes, the argon robot, named after my grandmother, produces age spectra with remarkable level of detail and precision, enabling patterns to be recognised that hitherto were lost in the scatter caused by contaminants and different measurement strategies. The hidden benefit of the method is that each heating step in itself acts as a diffusion experiment, thus allowing identification of the essential characteristics of different gas reservoirs within the grains. In turn, these characteristics identified through Arrhenius data allow correlation of the measured ages with the already recognised microstructural components. Modelling and simulation then allow inversion, producing a temperature time curve identifying the timing of individual mineral growth events and distance from the heat source. The temperature time curve can also be interrogated to yield paleo-depth, how deeply the rock was buried when it was at the measured temperature. In collaboration with the National Drilling Initiative, we are able to produce event sequence diagrams that can be used to barcode potentially fertile metallogenic sequences. The workflow was developed during an earlier project aimed at getting the most out of your date and has been successfully tested over several NDI campaigns. The current project is aimed at upscaling capacity and providing an ongoing legacy. The project has already identified otherwise unrecognised but now thought to be widespread patterns of cryptic metasomatism associated with fault and shear zone movement, sometimes with fluid percolating up to 5 kilometres from the active structure. Moving forward, we will refine and apply this workflow both on legacy samples and during NDI campaigns. The National Argon map will be reinvigorated with the ability to show paleo depth variation through critical times. We will barcode the tectonic signature of metallogenesis with the dynamic aspects of new code capable to show and delineate brief flashes of potentially mineralising fluids. This is a powerful method to add to our toolkit being developed in the NDI to allow us to rapidly characterise the mineral potential of buried frontier terrains.
MinEx CRC has developed a unique borehole electromagnetic sensor system which will make multiple petrophysical measurements during a single deployment to push towards new frontiers of rock characterisation from drilling. MinEx CRC recognises the critical role of drilling in mineral discovery and mine development. An objective of MinEx CRC is to deliver new, cost-effective technologies that add value to every metre drilled. Conventional borehole EM sensors are part of the mineral exploration toolkit, but deployment in angled, unstable holes is problematic and their functionality is limited to single or sometimes dual frequency settings. MinEx CRC's Curtin University-based research team has developed and are patenting an entirely new way of making in-hole multi-frequency measurements, logging while tripping and logging while drilling deployment, significantly reducing risk associated with hole collapse. Compared to conventional induction logging, the MinEx EM sensor has potential to deliver 1. Multiple geophysical parameters, 2. Greater depth penetration, and 3. Greater resolution. The MinEx EM tool will have broad application for geophysical characterisation of up to tens of metres around the borehole, with direct application in identifying and characterising high electrical conductivity such as massive sulfides. Based on test results so far, we believe that the new multi-frequency EM tool has the potential for significant impact in the mineral exploration drilling market, enabling multifunction EM logging as part of routine drilling practice. A patent application has been submitted to protect this innovative new technology, and MinEx CRC are working with our participants to define and facilitate a pathway to market that will provide the best opportunity for widespread utilisation of the tool. In the meantime, our researchers are assessing the potential for new in-hole time domain EM tools with potential to impact the market. Stay tuned for future developments in this space.
The goal of MinEx CRC's education and training program is to graduate 50 students on MinEx-related research and to influence the training of vet students in aspects of mineral exploration and drilling. We have 55 students registered as MinEx CRC PhD or Masters by Research students, and these are distributed across all 3 MinEx CRC programs and as company-sponsored projects. The focus of the Education and Training Committee is now to change from onboarding students to completing our students. To date, 15 of our students have qualified for their degree. We have established support programs for our students to give them an experience beyond what they would normally get if they were not part of a CRC program. This support includes that every student has an industry co-supervisor, and that industry co-supervisor is able to help them with their research project and also provide each student with mentoring. We facilitate ways that the students can connect with various people across the CRC community, and that includes representatives from industry and service provider companies. We involve our students in our annual conference every year, and we facilitate a forum whereby the students can give presentations to the MinEx community. In addition to our postgraduate students, we have 27 honours and 25 Masters by Coursework students who have completed their studies on MinEx CRC related research. In the vet space, we have been exploring education and training using digital visualisation. We have developed a navigable, highly realistic Roxplorer coil tube rig and HPS system digital twin in a virtual reality environment. An augmented reality Roxplorer model for easy visualisation of an optimised drill rig model at real or minimised scales has been developed for iPad or iPhone devices. The VR digital twin environment and AR models have been used and will be further developed for training and promotional purposes.
As we near our third and final stage of MinEx CRC research, our focus as an organisation will shift to the commercialisation of our technologies. We'll be holding an open day on Tuesday the 4th of June 2024 at the Fraser Suites in Perth, Western Australia. Join us to hear from key industry representatives from the Northern Territory Geological Survey, IMDEX, Rio Tinto, CSIRO and DigCT on the value of MinEx CRC pre-commercial products set to enter the exploration market. An agenda and registration details can all be found via the homepage of our website.